Hi, I'm Stacey Paterson here at the Sydney Institute of Agriculture with two of my favourite researchers from the Institute. Could you please introduce yourselves?
Hi, my name is Budiman Minasny. I'm a professor in soil landscape modelling here at the University of Sydney. My research is trying to find out why soil varies in space, or what controls that soil so that it changes in space and over time. This is in a broad term what we call as pedometrics, and I also do digital soil mapping.
Hi there, I'm Brendan Malone. I'm a researcher here at in the Institute. My research is around the digital soil mapping space, the soil spectroscopy space, and just in general in the pedometric space here within the Institute.
So can you explain in a little bit more detail what digital soil mapping is?
So digital soil mapping simply is an automated way of making soil maps, or the modern way of soil maps. So traditionally to make soil maps, people have to, or surveyor have to go out in the field and look at the landscape, and then they come back in their lab, and based on the satellite imagery or the topography, they're going to delineate manually what they think the soil will be in the landscape. So in digital soil mapping, we try to automate this process.
Yes, it's a computer assisted process, taking observations and soil observations and coupling that together with some remote sensed information, terrain elevation model information, and then combining all that data into a model framework so that we can take our observations and then estimate soil variation across space.
So why has this change towards digital soil mapping been important?
Yes, so digital soil mapping is really important, more so now than ever, because obviously soil is finite, and the pressures put on soil has become greater and greater over time with population increase and the demands for more food and more production from our soils. So therefore we need to have a much better indication, a better mapping of the status of our soils, and we need to have in place better ways to monitor the soils. So therefore digital soil mapping is really crucial to delivering that sort of information for better management.
So it allows a more precise map than traditional methods?
Yeah, we think it does. It gives you a bit more very localised predictions of soil information, whereas legacy soil data is quite vague and not very specific at a local scale. Digital soil mapping can give you that, and you can get some sort of estimate of the accuracy of your map, as well as some sort of measure of the uncertainty.
So what else can you use digital soil maps for?
So there are lots of use of digital soil maps. For example, at the COP21 a couple of years ago in Paris, there was an initiative from the Ministry of Agriculture of France to increase soil carbon by 4 per mil, or 0.4% every year. So in order to do that, we need to have a map of soil carbon stocks in the world, or the soil carbon stock at different regions, so that we can optimize how much carbon to be stored in the soil. And this is illustrated in Jose Padarian's presentation a while ago on the soil carbon in the world.
Yes, and also before in Damien's talk in regards to the soil security, where there's quite a large effort these days in terms of how we quantify soil security. And one example of this is to assess the productivity of soils, how they can produce biomass for food production and for fibre production. The example there is in Tasmania, where we've had a large project over the last few years in terms of quantifying the soil's productivity to support a number of agricultural enterprises, from cropping enterprises through to horticultural enterprises such as wine grapes, hazelnuts, for example. So essentially, for that type of analysis, you need to have digital soil mapping that can inform you the suitability for those types of enterprises.
So you can use digital soil maps to save the world or to feed the planet?
Both.
So do you offer training in digital soil mapping?
Yes, we offer training in Australia and all over the world. So we have traveled all around the world from in Europe, North America, and Asia to do the training.
Yes, our workshops are 2 to 3 days, or could be more. These are hands-on workshops with a lot of interaction between us as presenters and the students, and hands-on in that the students or the people that come along to our workshops are sitting in front of a computer, and we're going through with them exercises on all sorts of things related to digital soil mapping.
So it's an interactive learning process?
Completely, yeah. So it's really important that students are given a hands-on feel, or given some real data sets to play with, so that they can sort of better understand, like the concept of digital soil mapping is pretty clear, but how to apply that in a very practical manner is another thing. So it's really important for us to sort of here's some data, here's some examples of a workflow of digital soil mapping, and then it becomes an easy way to sort of learn and for the students to understand.
So I understand that you've written a book about digital soil mapping and how to apply digital soil mapping using R. Can you tell me a bit about that?
Yeah, sure, Stacey. This is our book, using R for digital soil mapping, and we published this with Budiman and Alex McBratney, and this was published earlier this year. And indeed, it's a course or a curriculum in how to do digital soil mapping. In this case, using R.
So this book complements the course that you were talking about earlier?
Yeah, indeed. Yeah, definitely. So, like from all of our workshops that we've ran over the last number of years, we've compiled a number of exercises and materials from those workshops. And essentially, this book is a compilation of all those exercises and materials. So it's more or less a one-stop shop for all digital soil mapping. So digital soil mapping isn't just one thing, not such about creation of digital soil maps. It's a whole group of exercises and workflows.
And the book is called Using R for Digital Soil Mapping. Why do you use R?
Yeah, well, I think R is very general, it's very user-friendly. For digital soil mapping, there's 3 things that you want to do. So you want to do some data analysis, you want to do some GIS sorts of exercises, and you want to create some maps. And all those things and more can be done in R. And because it's a relatively easy sort of computer programming language to learn, it makes digital soil mapping pretty easy and pretty straightforward, and then you can get everything in one software.
So for anyone who's watching who's interested in using R for their own digital soil mapping, where can they get access to these codes?
Yes, you can get all the codes in this book in our website called www.digitalsoilmapping.com. So where you can download all the codes and use it for your own mapping.
Well, thank you so much for your time and sharing the exciting world of digital soil mapping and how we can use it to make better maps, feed the world and save the planet.
Yeah. Thanks, Stacey. Yeah, get mapping and using R for digital soil mapping.